Hello. I'm going to get us started because we have a very full session this morning. Welcome to Symposium 30. I am your moderator, Holly Little, and my co-moderators are over on this side of the room, Erica Krimmel and Talia Kareem. This also serves as an introduction to the first talk because I'm going to get us started. This year's meeting was made possible in part by the generosity of our sponsors, especially the diamond sponsors that were just on the screen. And we are grateful to them and to the organizers and for the tech for today's session. This session will be recorded for later viewing. And if we have comments and discussion, which we hope that we will, please continue using the Oxford Abstracts area later. I think that covers the main bits. Thank you for joining us. As I said, we have a full session. Can you bring up the first slides, please? Thank you. So this is the Spnhc to Tdwg Bridging Communities and Building Capacity for Digital Collections Mobilization session. Thank you for joining us. We are the organizers of the session and the presenters of the first talk. So this session is going to be split across today and tomorrow, same time, same place. As I said, today we have a full list, so we'll try to keep to time, 10-minute talks, 15 minutes overall with transition and questions. But at the end of tomorrow, we will have about 15 minutes for discussion if we stay on time. And we're really excited to have kind of the variety of talks. So thanks for submitting them for the people that will be speaking. I think I've always found this journey between Spnhc and Tdwg very personally like challenging opportunity. It's awesome, but also comes with a lot of interesting discussions. So I'm excited to see where this goes. Okay, I'm going to get started. So again, I'm Holly Little. I'm presenting an information ecosystem map of resources supporting the mobilization and discovery of paleontological specimen data. So what I'm presenting in this talk is kind of what led us to organizing this session. As we started to think about how can we bring together more people around this idea of what paleo data is, or more broadly, biodiversity and natural history collections data, and bridging gaps between the different perspectives and roles and positions that work within that space in the larger data landscape. So my co-authors and I have been working on this and having that conversation for a long time, and many of you in the room actually have contributed to a lot of the work that has led to today and to this U.S. National Science Foundation project that we're now working on, community-driven enhancement of information ecosystems for the discovery and use of paleontological specimen data. So really the impetus of this project is to do a lot of those community discussions and community building to try to bridge those gaps and try to create better community knowledge and community understanding around how we create, work with, mobilize, and publicize paleo specimen data. And we think that even though I'm going to be talking a lot about paleo for this talk, our idea and our intention is that this should be adaptable to any other discipline within our community as well. So the goal of that NSF project is to do a lot of conversation and engagement, but also a lot of analysis and evaluation to gain a better understanding of what the open data landscape is to improve discoverability and use of paleontological specimen data, and getting a lot of community feedback into that so we can map out what the future for paleo data should look like and what the data landscape needs to be improved to better support paleo data. We know that there's been over $10 million spent over the last 10 plus years to digitize fossil specimens, resulting in about 8.9 million records mobilized on GBIF. But we don't necessarily know who is using that data. Is it truly discoverable even if it is on GBIF, because there are challenges with mapping that data to things like Darwin Core? Is it integrated with global systems because they're often created to support more modern extant biological collections and data, not necessarily with fossil specimen data in mind? And then do the data publishers understand the many data pipelines that they need to be able to work with to really make their data accessible to a broader audience? So involved in this project are the three of us that are here representing the University of Colorado Boulder, the Smithsonian National Museum of Natural History, and then our partner Lindsay Walker at Arizona State University, who might be online, I don't know. She is. And then the other partners that you see listed here. And we're also working very closely with our ecosystem partners at places like Catalog of Life and at Tdwg, Spnhc, and at GBIF. And really, I just wanted to show this to emphasize this is a huge community effort. We can't do any of the work that we're posing to do, even just the people listed on this slide. We need input from all across the community, all across the ecosystem that we'll be talking about. And that diversity of perspectives and roles is really critical to that too. So what is the Paleo Ecosystem Map? To help us answer these questions that we've posed, we want to kind of, for ourselves, but then also something that we'll be able to communicate back to the community, develop a really well-documented understanding of what the data landscape is and how it impacts paleo specimen data specifically. So as an ecosystem map, you've probably seen a lot of different kind of diagrams like this, knowledge graphs, other Venn diagrams, other things like that. And a kind of brief way that we've been thinking about it is it's a finding aid for our community's collective knowledge. So you might only know about like one portion of one of these graphs. Perhaps it's just the yellow portion here. That's fine, because what we have is a collective community, is collective knowledge when we can start linking it together and show what the impacts are of the section that you work in on those other sections of the graph. And I think one of the things what we really want to try to do is lower the barrier of entry into this space by making it more understandable to a broader audience. So if you are only working within one space, it's not a mystery to you how what you're doing relates to or impacts something all the way across the landscape in a different area. So what will the paleo ecosystem map look like? Where will be a model of the existing information and systems landscape created by identifying entities. So what are all those different pieces within our landscape that we work in, define how they interact with each other, and address how they're used for fossil data. The structure will have the entities defined, and then we're coming up with a schema for defining what the attributes of those are, or ways to describe them in a standardized way. So even if there's a lot of variety in the entities, we can kind of compare them and talk about them with similar language. We want to have a flexible data schema so that we can have some more specific attributes depending on the part of the ecosystem map we're talking about. And we're still kind of working on what the actual structure of this map would be, but we're leaning towards a graph database. And we are very happy to have your feedback. We'll have a mechanism for that at the end. So if you have ideas of how to create something like this, please let us know. The entities, like I said, could be a variety of things. They could be a primary source. It doesn't necessarily have to be digital, but what we will be doing is noting if it's digital or analog, and if it needs to be digital. It could be a tool, it could be a data portal, both for an individual, like local museum collection, for example, or for a global aggregator. It could be a standard, an exchange format, an act, just an organization or an institution, a concept, documentation. It could be a pretty wide variety of things. But again, what we're going to try to do is create that standardized language about how to talk about all those within this same ecosystem. And I think most importantly to this is the people part of what we're trying to do. So the audiences are really critical to making sure that we are able to really create this ecosystem map and make it usable to a broad array of people. So that could be people new to the paleo data community or new to the data community for collections and biodiversity, really. And that might be that they've been doing digitization for a long time, but they're new to trying to access and understand how they participate in this larger global landscape of things. People with deep expertise in a specific sector who need broader knowledge. So maybe they only work in that yellow portion, and now they want to understand more about how what their work is doing and how their work impacts what is happening in other spaces. And then people working to integrate across initiatives and systems. So for example, that's what we're doing in our project, trying to understand the whole landscape. So once we have this ecosystem map, what should it do? For our purposes, for our project, we want to be able to identify the mobilization pipelines for paleontological data. We need to be able to identify what the core infrastructure is for really making the paleo data known and useful. But we also need to know what the gaps are so we can outline a roadmap for how we can move forward as a community to better support paleo data. We want to engage more people in this process, more expertise. We need to build new partnerships to do that forward-looking work. And one of the really key things that we want to do is engage the research audience more and help them better understand how they can use our paleo data and how they can use these information systems. So this is kind of where we are at right now, is working on listing out what the entities are and working on that schema for how we're going to describe them. So here on the left, you can see example entities, and then we'll have a set of core attributes that each entity is described with, and those are shown on the right, at least an initial list of them. And then, like I said before, we're planning to have some more specific entities for specific sectors. So a really key one for this kind of the challenges within the paleo data world is taxonomy. So we will have very specific descriptors that we need to use for any system or entity that relates to taxonomic information. So for example, this is an idea of what the ecosystem map could do for us once we've completed it. Both in the lower right corner, you have a physical specimen. And from that physical specimen, you could have two different processes, one of which is the specimen information that you have within your local CMS, and then you're publishing to GBIF, and the data providers from collections are putting together and publishing. The other, going towards the left, is the process of assigning taxonomic identification and the process of publishing that name, publishing that specimen, how that name is managed within taxonomic authority systems, and then how it also ends up in GBIF. And one of the challenges in paleo data is sometimes there are disconnects between the name as it goes through the taxonomic pipeline and the name as it goes through the collections pipeline, and then when it gets to GBIF, they are misaligned. So the ecosystem map should help us better understand where the challenges are in those different pipelines that make that disconnect happen. So we have use cases that we're trying to develop, and we're really interested to hear from you of how you might be able to use a map like what we're developing. The ones we're presenting here are very taxonomy focused. So an idea of what we're doing, trying to integrate across initiatives, is understanding why the fossil taxonomy isn't represented well, what are the solutions that we might need both at the data aggregator level, the taxonomic authority level, the data provider level, the publication level, and then working to kind of tie all those pieces together. And we need, important again, is we need input from people that exist, that work within those other spaces of the ecosystem map and at different levels of the ecosystem map. And then again, and then also those people that work in very specific sectors, they might need to know what the most current higher taxonomy is for their specimen, or what the taxonomic resources are that are recommended or are integrated into the systems like the Catalog of Life, and how they are being used within GBIF. So we would really like your input. We have some questions in the Google Doc linked here to get ideas from you of how this ecosystem map could be built. What are tools? What are examples that we could look at? What you'd like to see from it? How could it be useful to you? And even if you're not in a paleo field or collection, we still would really like to hear your thoughts, because like I said at the beginning, we are hoping that this will be adaptable to other disciplines, even though we're very focused on paleo data right now. Yeah, so none of this would be possible without the larger community that we're working within. So we're very thankful to the Paleo Data Working Group, GBIF, Catalog of Life, participants in our grant-funded activities, and all of you preemptively as you go into our Google Doc and provide input. Thank you. And I did very bad and don't have any time for questions, so 1 second. I will just note, we will be around. You're welcome to come up to the three of us and ask questions both about the grant project and the ecosystem map at any point. Okay, up next we have Katie Pearson.
Hi, everyone. I'm excited to talk to you about a project that I was working on a couple of years ago and still kind of work on. And when I looked at this symposium, they were asking for kind of examples of and best practices from sustainable ecosystems of biodiversity data. And so I'm hopefully going to provide you an example of what I think is one, and also some lessons learned about how I think we can achieve that, or at least some things that will help us achieve that in the future. So my name, again, is Katie, and my background's in botany and phenology and biodiversity systematics. Right now I'm working as the project and data manager for the SYM30 support hub. So we support SYM30-based data portals. I'm the node manager for the SYM30 support hub node of GBIF, and I've also worked in some data standards in plant phenology. And I'm located in California, and that's why there's this little star here on the map. So I was also, a couple of years ago, the project manager for the California Phenology Collections Network. And this was a digitization project funded by the U.S. National Science Foundation that was coordinated across 28 collaborating herbaria from 2018 to 2023, with the pandemic thrown in there. And our goals were pretty basic: to image 1 million herbarium specimens, no sweat. And then also phenologically score 1 million herbarium specimens. So get a status of flowering, fruiting, budding, et cetera, on those specimens. We were also to create a new data commons for California herbaria, and we did that in the form of a Symbiota portal called CCH2, the Consortium of California Herbaria, our second portal. And we produced some specimen-based angiosperm phenological traits. So we came up with a scoring schema that we were able then to map to the Darwin core and then share as extended measurements or facts. This was a very successful project. We were able to surpass all of our imaging, phenological scoring, georeferencing, and transcription goals. As you can see, we got over 180% phenologically scored, so we were doing really well in that regard. And I think a lot of our success is well represented in the stats relating to our data portal. So currently, the data portal contains over 4.9 million specimens from California herbaria and herbaria that have large California holdings. And this graph shows the growth over time, and that's only the growth until 2022, so there's been growth even beyond that. We have over 2.6 million images in this portal right now of specimen records, and over 1 million of those were created during that 2018 to 2023 period, and they continue to digitize to this day. And we have over 1.65 million specimens that are phenologically scored. And critically, from that 28 institution collaboration, we've now built a portal that incorporates over 90 collections. So these are herbaria, small, big, across the state, and some partner institutions that have lots of holdings in the California floristic province. And all of these have come together, and many of them have been able to use this portal as their data management and digitization platform. And this collaboration that started with just a handful of herbaria across California has been able to evolve, spread out, and involve the larger community. And so I would call this particular portal community, well, here's a map of those 92 collections. I would call this a sustainable open ecosystem of digital biodiversity data. So this strong thing that we're trying to build, because we have been able to integrate so many collections, especially smaller herbaria that would have never had the expertise or the person to go to ask about how to digitize their collection. So I posed the question to myself, why did this work? Why were we able to build this community? And I think it comes down to many factors, but I want to point out two specific factors that I kept on coming to when I was pondering this question. One of them was that we had a shared data commons, a place where we could work together. And then another one I found was that we had resourced support people, and I'll go into a little bit more detail about what I mean about that. So in terms of our shared data commons, again, like I said, we had this central CCH2 Symbiota-based portal, and there were a lot of reasons why having this portal contributed to our togetherness and our sustainability. So Symbiota portals are central ecosystems for searching, managing, and tracking progress of the grant and beyond. They are both a biodiversity data aggregator, so you can go and just search for data, you can map data across multiple collections, but they're also a central database, and they have a lot of digitization tools baked in. Very critically, during the pandemic, we were able to use this CCH2 portal to do remote work because Symbiota portals are web accessible and they enable remote, distributed, and collaborative work. So these are just some screenshots of data entry and georeferencing tools that you can access just from a browser. We were also able to leverage this cooperative and collaborative framework to integrate people who are kind of beyond the collections community. So we brought in a bunch of expert botanists and just geologists and even kind of geographers who know a lot about the maps, the places where all these specimens were collected. And we built this 100 Club is what we called. We tried to get 100 members. To do georeferencing, and they were able to do that directly in the data portal. They didn't have to travel to an herbarium. They didn't have to physically handle any specimens. We could just give them access to the data, and they could make the edits straight in there. We provided e-training, and then they could do the georeferencing. And we meet via Zoom. We still meet via Zoom monthly because we just like each other so much. Symbiota portals also include tools to reduce duplicate effort. So there's the ability to copy data from duplicate specimens and also duplicate georeferences. And here's an example of a coordinate cloning tool that we use. Okay, but a big point that I want to make is that this is one example of a project that was able to take advantage of well-resourced support people to support the whole community, and I think this can be used in other projects moving forward. So the leadership of this particular project was, we had our lead PI, Jen Yost at Cal Poly, and then there was a full-time budget for a project manager. And this project manager was not someone who was also collection manager, who was also something this, something that. This was their main job. It was me, but it was their main job. That was all I did. And then we also had some support from Jason Alexander and Ed Gilbert at other institutions. And from this example, I want to make the point that small teams of resourced expert support people can have an outsized impact on creating sustainable open ecosystems of digital biodiversity data. And I say this for several reasons, and this is especially in the case of our shared data commons, but there are a lot of shared data commons out there. So resourced cross-network support people. So these are people that are kind of the center of a certain community, or people that you know you can always ask. But not just that, they have the resources to answer you in a timely manner. And this is not always done in our community. We have our people like Siobhan Leachman, who you can always ask about Wikidata, but I don't know if she is paid at all probably by some projects now. But the points I want to make here is that resource cross-network support people, they can provide a personal gateway into an often complicated and technical ecosystem. So for this project, I went and visited all of the individual institutions prior to or at the very beginning of the project. And I was able to help them build up their workflows, meet the people, so then they had this personal connection. They're not just going into an internet full of technical jargon, trying to figure out how to digitize, how to mobilize. They have a person that they have an email address for that they can go to. And I think that's really important on a very human level, that we want someone that we can talk to and we know their name. In this position, I was also able to draft and manage protocols, workflows, trainings, videos, et cetera, based on the research that I had time to do because I was, again, fully resourced. So we developed these workflows and protocols. We were able to make a bunch of YouTube videos, a lot of trainings. We even had a georeferencing training course that had modules and assessments. And again, that's because we had a person dedicated to do this. We even had these monthly meetings where we would walk through certain aspects of the data portal so that people could come in for a short training. So this meant that the data providers didn't have to start from scratch. Nobody had to look at that blank sheet of paper and say, how do I tell someone how to image a specimen? They had something to start with. Another important point, I think, is that they were able to get timely answers to a diverse amount of questions, from digitization to mobilization to, hey, I don't know where to get paper. What I have noticed is that there's kind of this punctuated equilibrium of people's attention to data-related tasks. And so if you didn't answer that email within like a month, like they're not even going to remember sending that email if you haven't answered. So having people who are dedicated support people who can answer in a timely manner, I think is really key to the success of moving projects forward. And then of course, there's just that you have a person who knows how to deal with data. So you have someone who can perform data heavy functions, and that doesn't have to bog down the people who are dedicated to doing mounting and managing volunteers. That's kind of beyond some folks' wheelhouse, and that's okay. So the data providers also don't have to learn all the latest tips and tricks and standards and best practices and breaking developments and know all of the acronyms of the alphabet soup that are out there. You have a person who can connect those together, kind of be a personal graph of all of those connections, and be able to make those connections for people. And all of these pros I have seen come also to be important in my work in the Symbiota Support Hub, because we're also resourced support people. But I use the California Phonology Network as just one example of this. So again, there's my thesis for part of my talk, and I want to make the recommendation that we can consider pooling resources among organizations to help make this happen. Maybe they need to be slightly regional, maybe they need to be focused on one taxonomic group, but I'd like to consider the idea that maybe there shouldn't just be a California Phonology Network person. Maybe there is a better and cross-funded position or positions for folks who can make those connections between people. So we're not just relying on volunteers to do all of the connections for us. So with that, I'd like to thank, again, the folks for organizing this session, for you for being here, and from our sponsors. Thank you. And I think I have time for questions even? One question. Okay. Please come up to the microphone.
I just wanted to thank you for putting the georeferencing training materials on the CCH2 portal, just because, so I'm on the other side of the country in a different thematic TCN, and that is where I send students to learn how to georeference. And I just, those types of resources that are really beautifully produced and have a home because of your efforts can have a very long lifespan in terms of their impact. So it's not just you build it and it dies. continues.
Yeah, thanks for that. And that's just an example of, again, like this doesn't need to be a California specific, or these networks can be much broader than they have initially been funded for. And so if we can fund them more broadly, that seems like a great use of everyone's time.
Thank you, that was great. Next up, we have a recorded presentation from Teresa Mayfield-Meyer, and I think she is also online for questions after? Yes, okay.
Natural history collections are inherently interdisciplinary and thus rely on expertise from diverse domains. In an effort to benefit from such expertise, collection management systems may attempt to rely on broader community resources that offer access to authoritative information. These resources may not be purpose-built for the collections community and so require manipulation or even digitization before they can be used. They also often have a fragile existence, perhaps entirely dependent upon a single institution or person. What happens when a resource is orphaned, gets an update, or completely disappears? If it seems like important resources are precarious, then you are probably working in a natural history collection. Let's look at some external authorities used by Arctos that I hope will start a discussion about how sharing the maintenance burden of such resources might make them more sustainable and responsive to the needs of the collections community. Arctos has relied for over a decade on global names to check taxon names and get classification data. It's been a reliable and awesome resource, but many in the Arctos community have decried the fact that it's not always easy to determine the validity of a name in global names. And there may also be issues of datedness that are to be expected when one person is maintaining a large resource. Although global names includes the taxonomy from the World Register of Marine Species, or WORMS, Arctos members soon found that it wouldn't be enough, because they needed APIA IDs to pass on to the Ocean Biodiversity Information System, OBIS. This meant that Arctos had to get data directly from the World Register of Marine Species instead of the easy path we have from global names. The result is a clunky and not easy to update partial version of WORMS taxonomy in Arctos. It seems like the APIA IDs would be important across the community, but that's just an assumption. The Global Biodiversity Information Facility, or GBIF, has some information about how funding was supplied to create global names. But how are its ongoing operations funded? If something were to happen to Dimitri, would this resource be maintained? If so, how hard would it be for someone else to step in? In the last couple of years, the Arctos community decided to let go of higher geography and the large geography table it was maintaining somewhat haphazardly, and instead to rely on GATM for terrestrial geography and some slice of IHO World Seas for marine geography. GATM is another fairly awesome resource used by many in our sector that may be never-ending as claimed on its About page. But is there any funding, and are there enough maintainers to ensure its never-endedness? After adopting GATM, the Arctos members quickly found gaps and errors in the data. This again is to be expected of data resources, especially ones that are representing lines that can be redrawn on the daily by humans. The oldest outstanding of these issues was opened in October 2022, shortly after GATM was adopted, and there are at least eight that were open in the GitHub repo as of the middle of August 2024. It also seems that whatever is available via the GATM API does not match what is visible on the GATM site, which indicates that updates and releases have ended, or at the very least are not happening as planned. Limited availability of the GATM maintainer and limited ability to maintain focus on the issues in Arctos means the list grows and the omissions or errors pile up. Strict reliance on an external tool means that data cannot be properly recorded in Arctos if it is incorrect in the tool. I won't even go into the fact that the spatial data in GATM may not accurately reflect historic polygons in legacy data. Geolocate has been the tool of choice for many georeferencing projects. Arctos has been using Geolocate to allow georeferencing from within Arctos for over a decade. I would guess that this is one of the more ubiquitous external tools in use by biological collections, especially during the digitization process. But that's just a guess. It's good to see the long list of contributors to the project, but there's no mention of funding. This also brings up the issue of hosting. People move around. Where are all of these digital tools hosted? What if the hosting entity decides to end their free hosting, or the maintainer moves to a new institution that refuses to host? Maintained by the International Commission on Stratigraphy, or ICS, the International Chronostratigraphic Chart is a mainstay of paleo and geology data. While the chart is a lovely visual, it isn't very useful from a database perspective. There's supposedly a geobiodiversity database that is the formal database of the ICS, but for the life of me, I cannot get the site to open. It might be my firewall blocking an address in China, but it means that all I have for chronostratigraphic data is the chart. So, in my massive amounts of free time, I turned the chart into a table that could be used as data for Arctos chronostratigraphic attributes. This table has not yet been adopted because there is a lack of time, people, and resources to test its ability to meet everyone's needs. But I will provide a link if anyone else wants to use it. At least one other person has reviewed it for accuracy, thank you, Nicole, so there is probably some error in there somewhere. I feel certain the ICS will maintain its chart, and when the next version is released, my data will be out of date unless I find it in my heart to update it or someone else does so. This is an example of a well-maintained resource that just isn't useful without some manipulation, and that manipulation must be repeated with every new release of the original product. I will also point out that revisions to the chart mean that data may be changed in unanticipated ways when a new table is introduced. Many of these resources contain a hidden temporal component that we tend to just ignore. Anyone participating broadly in the biodiversity data community is making use of Darwin Core, which is maintained by Biodiversity Information Standards, or Tdwg. Show of hands, how many in this room have participated in development or maintenance of Darwin Core? What about any of the other standards maintained by Tdwg? How many have held or are holding a leadership role in Tdwg? Thank you all for your service. Now I have to wonder, was this service your own time, your employer's time, a bit of both? Volunteering to get your paid job done is unacceptable and in some cases illegal. Don't get me wrong, community participation is needed and makes everything better. But when some can participate in a paid position via an employer who allows it, or maybe isn't aware of it, and others are taking up their free time, it doesn't lead to a healthy community. We've looked briefly at some external resources that may be important to the biogeodata community. What have we learned? It may be difficult to determine if a resource is well-funded and sustainably maintained. Few of them openly advertise their paid contributors or funding mechanisms. Some of these resources may not even be aware of our community's needs and might be able to supply more usable versions if they were. We can't really tell when a resource qualifies as in use by the broader community and therefore necessary. And the biogeodata community would benefit from acknowledging and supporting these types of resources. Facebook is free, but you do give them something. I might say that GBIF is free, but the global community is actually paying for it. If we want to have useful tools for the whole community, we need to figure out how to sustain them. This means paying people with appropriate skills and ensuring that the necessary infrastructure is available. I am grateful to the Arctos community for bringing these tools to my attention and for making attempts to use external authorities. I would also like to thank all the passionate people who build and maintain these authorities. Thank you for listening, and now let's chat. In the time we have left, I'd like to look at these 3 questions. Please feel free to add responses in the Google Doc. Maybe they will help us start the list of community-wide tools we need to support. The document also contains all of the links presented in this slide deck. What external resources are you using? Are you or your organization paying for any of the resources you are using? How do you think passion projects can be maintained after the passion or the passionate person is gone? Thank you for participating today. I look forward to future conversations.
Thanks, Teresa. That was great. And I think probably the hand raising went about exactly how you expected it to go with your questions in the room. And we have time for a question or 2. Oh, you need the roaming mic? I don't know if we have one. And then I'll repeat. Yeah.
Matt Yoder on Zoom wants to say that one huge plus to the sustainability of a biodiversity informatics project is its code quality, something almost never discussed in these types of forums. Here, in my opinion, Global Names is world class. Its architecture, documentation, API, and set are truly great examples of how to code a project for longevity.
Thanks. Erica just read Matt's comment from the Zoom chat to the room. So people online, you should be able to see it. Sorry, we don't have a roaming microphone. Okay. So next up, we have another recorded presentation from Samantha. I don't think she's online for questions. Oh, she is online. Okay, yes, Samantha is online if you have questions following her presentation.
Hello, everyone. Thank you for having me here today. My name is Samantha Arellana. I am a PhD candidate at Arizona State University and the International Communities Coordinator for the SYM30 Support Hub. Today, I am very excited to share a little bit about our work with digitization and mobilization of natural history collections in Guatemala. To give you a little context, Guatemala is part of Central America, and most of its collections are in academic institutions. Collections are endorsed by the Guatemalan government and need to be legally registered to obtain collection permits. Registered collections are in 2 universities, San Carlos University, that is the public national university, and Del Valle University, that is a private academic institution. So if we go back a little bit to early 2020 and we search for specimen records for Guatemala, we would find only one Guatemalan collection represented online. This was the mammal collection of the public university. A little over 4,000 specimen records were mobilized to GBIF with the help of Bernat. The rest of the specimen records for Guatemala had been shared by institutions in North America and Europe, mainly collections from the US, thanks to the digitization initiatives by IDIC-Bio. So in 2020, several things happened that made us pay attention to collections digitization in Guatemala. First of all, we discovered SYM30, and SYM30 is very easy to use because several online portals are already available for collections to be incorporated and just start digitizing. So it was really easy to start talking to curators about this collection management system for their collections. So, of course, then COVID happened, and with collections now on lockdown, there was this new urgency to make the data available. So this also helped to motivate collection managers to participate in this intense campaign that we started to promote digitization. We had some online talks and we started working on several SYM30 portals for entomological collections, herbaria, vertebrate, and marine invertebrate collections. So if you want to learn more about SYM30, there are a few more talks in Symposium 10, 28, and the demo camp by the SYM30 Support Hub. So after a few months of working on 4 different SYM30 portals, a customized SYM30 portal was born specific for all types of collections in Guatemala. This included plants, animals, fungi, and even fossils. So, of course, like all SYM30 portals, this is not only a collection management system, but also a GBIF installation, a mid-sized aggregator with many interactive tools. And what really made this portal special and a major hit in Guatemala was translating the front end to Spanish, which enabled the access to many more local users. So basically, this portal was really the start of the digital collections era in Guatemala. You can use the QR code to visit the portal. So this platform is also very special because it's mainly used as a live management portal, which means that we are not uploading copies of the data. We are actually using the online profiles to actively digitize the Guatemalan collection. So each collection has its own personalized profile with a public and admin version. The admin version includes a data editor form, batch georeferencing and data cleaning tools, loan management tools, and a Darwin Core archive generator, among other very useful functionalities. Here is how the data editor form looks like, and the instant public record that is available right after transcribing the label information or adding the specimen image. Additionally, collections can share their data instantly with GBIF, and the direct management profile allows to edit the data as many times as needed, facilitating the data cleaning. If you go, if you're logged into your SYM30 profile and you go to GBIF and click on the reference link, you can go back directly to the public view and to the editor form. So, so far, this process is repeated almost daily in 35 virtual collections and 11 observation projects in the Guatemala portal. More than 51,000 specimen records have already been digitized, and This includes more than 15,000 images and more than 1,000 type specimens in the collections. You can follow the QR code to check all available records, and you can also generate the map in the Map tab. This portal is mostly used to digitize specimens, but some specific scientific projects require the digitization of some observation records. To ensure a wider mobilization of all this data, the portal is linked to GBIF with a Symbiota installation. Currently, 24 of the collections share their data with this global aggregator, which has made it possible for collections to obtain over 300 citations in scientific literature and add associated researchers to Bionomia. Here we can see that actually most of the data managed in the portal, around 85%, is being mobilized to GBIF. We try to encourage the data sharing, but this is really a decision that each collection makes independently according to their management plans. So currently, 93% of all specimens available online published from Guatemala are managed in our portal. So as you can see, the numbers keep increasing with time, and most of the data is shared instantly with GBIF, which makes this portal a very active portal, producing and sharing data constantly. So all of this has been possible due to a lot of effort from the collection managers, researchers, students, and volunteers involved with the collections, and also because of the trainings and resources have been made available constantly. We've had numerous talks, workshops, meetings, and we write documentation and record tutorials in Spanish that also have opened the doors to reach out to more Latin American communities that join our activities because they are using other Symbiota portals or just because they want to learn about the platform. So you can also find us on social media as Guatemala Portal. So all of these activities are possible thanks to the support of a large team of people, including Santi Lopez, who has been the co-manager of the portal from day one. He is right now about to start his PhD program, working with biodiversity data in Austria, so that's very exciting. The IDIC Bio Symbiota Support Hub has been essential to maintain the portal and to have access to documentation and information that we have been able to translate for the Latin American community. So we also work very closely with the Guatemalan collections community to make sure they have the necessary elements to continue their work in the portal. Recently, we published a chapter in Spanish about the portal in the book Biodiversity of Guatemala, and it's free and available online. We were very excited to see many more chapters in that book that used and cited our portal. So please remember to check our abstract in the Biodiversity Information Science and Standards Journal, where you can find all the links and additional information. And if you speak Spanish, you're very welcome to visit our documentation site to learn more about our work. Thank you to everyone involved in the preservation and digitization of the collections in Guatemala, and thanks to all institutions for their support. Also, thank you for your attention. Here is my contact information, and now I will take any questions you may have.
Thank you, Samantha. We have plenty of time for questions.
Thanks, Samantha. I have a question for you. You are a grad student and you're doing amazing and really useful work. In light of Teresa and Katie's talks right before, how do you see the work that you are doing being sustained beyond your personal capacity to sustain it? Because it's so important.
Thank you, Erica. Yeah, that's a really good question. It's being actually, like it was mentioned before, it has been like a work of passion since we began this portal. And right now that I am about to finish my my PhD program, it's there's the question like, would I be able to continue to do this? And we're looking into options right now, so I can like keep working on this. But it's really difficult to think that I will have a job exactly to do this that I am doing. So yeah, it's a really hard question for me right now.
If anyone has a question for one of the previous speakers, we also have time. We have a little bit more time. Okay, we're trying to stick to the scheduled start times. Okay.
I want to know from kind of all the folks here, really, do we have good examples of well-supported like communities? What are the best examples of like, man, this group has the people and the money that is making this happen, and they have a sustainability plan? Like, is that GBIF?
I'm like, don't, I was good until you got to the last clause, and then I'm like, oh. One example of a functioning community that's open source that our group often points to that we have aspirations to be like someday is the Blender community. Does anybody here know Blender? Yes, so you all will know more about it than I do. So it is open source software for developing 3D pictures. Yes, people shake your head, I'm doing that right? All right. And so they grew from this sort of local small thing to this ginormous thing around the planet that, I don't know, thousands of people, tens of thousands of people use and support. So those are the people building the tool, contributing to it, making it better, building the documentation. So that thing has a life of its own, and it's not dependent on NSF or the EU Commission or any of that. So that answers the first part of your question as a model for what we can aspire to and how it can work. Is it easy to get that foothold? Like we at TaxonWorks are open source, and other people in here as well. We've just begun to see the fruits of somebody knocks on our door and says, hey, I want to write for you, what can I do? And we didn't say, please fix our bugs. We said, what would you like to do? Their motivation, their purpose, not our projection. And they said, so we gave them a list of options. Here's all the different things we've dreamed about having. And they took on 2 ginormous pieces of full stack software development for features we wanted to add, and they built it all. So they've now become part of our network. So that's part of an answer to your question. Totally. They had free time. They said, how much time? We said, how much time a week do you have? They said, right now I have like 2 days a week for like 6 months. We were like, oh, happy day, right? So we had a plan for that in mind though too. We have an open source development mindset. So we knew better than to say, just please fix our bugs for us, right? We knew that motivations are individual to each person, and to make sure we open that up and say to them, well, we have all these different things we love. Where is your happy space in all of that, right? That's one part.
Thank you. Okay, we're going to move to the next talk. Thanks, Samantha. Sorry, I should have said that after you answered the question. Next up, we have Jacob.
Okay, so today I would like to go over some of the challenges in sharing morphological and anatomical data in the paleontology community. But first, what do we mean by morphology? So in paleontology, Morphology is the specific anatomical part of a specimen. So some common examples you may run across are these fossil leaves of this soapberry plant here. We have a calyx of a crinoid. We have a tiny little eggshell fragment, and then we have these hind limb elements of a fossil vertebrate, specifically this tapir relative. And in paleontology, recording morphological data is super important because oftentimes only a small little piece of the entire organism is actually preserved, as you can see in these examples here. Plus, oftentimes, researchers are interested in only a small part of an organism because certain parts are more diagnostic than others. Thus, researchers really need to know which part of an organism you actually have. So some research examples include fossil mammal taxonomy is primarily based on features of the premolars and the molars. And if we didn't know that this specimen here had premolars and molars, then this research paper here wouldn't have been able to describe a new genus and species of early mammal. Bone histology for vertebrates is super useful to gaining insights into the life histories of certain organisms, and certain anatomical parts record developmental features a lot better than others. So for example, the femur, the humerus, some other long bones in the ribs. This research paper here was looking at the internal structure of femora of this early tetrapod at different developmental stages in order to gain a better understanding of its life history as it was growing up. So certain fossils, we like to look at the shape of the fossil in order to gain a better understanding of how that anatomical part functioned. So when you're looking at functional morphology, it also things like walking or eating or flying around, you need to be able to examine relevant anatomical parts. So this research paper here was looking at the locomotion of early turtles, and in order to do that, it needed to look at as many limb elements as possible from as many early turtle specimens it could get its hand on. The problem is, researchers really can't find the specimens they're looking for on data aggregators because morphological data is shared inconsistently or not at all. This means researchers must go and try to search for this critical morphological data on a collection by collection basis by going to each collection's online collection database. So here's an example from the Smithsonian National Museum of Natural History, where the red box is highlighting where that very critical morphological data is located. Plus, each collection is coming up with its own terminology or vocabulary for each individual single part, right? So here's an example of a heel bone of a vertebrate. This thing can be known as a calcrag, a calcaneum, a calcanei, calcaneae, a calcaneoastragalus heel bone, so on and so forth. So as you can imagine, if you're a researcher who has to go to multiple different online databases, searching a whole suite of different terms just to get at to the single part that you're trying to get at is a huge roadblock to your research program. Now, this isn't to say that you can't share morphological data with data aggregators. You can, but it is very difficult because there is no Darwin core term for morphology or anatomy data. And this leads to these paleo collections having to come up with their own best solution on how to mobilize this data themselves, which leads to these inconsistencies, or a lot of times people just get frustrated and they just don't share that data. For those collections that are sharing data to data aggregators, they're mapping morphological part data to Darwin core terms they believe are the best fit for this data, but they're really not. One of those terms is dynamic properties, which is really meant to be this catch-all term for measurements, facts, characteristics about the specimen, and not morphological part data. So some common paleo examples may include like the length of the femur or leaf damage caused by an insect. However, by far the most used Darwin core term to share morphological data with paleo collections is preparations. But using preparations really conflates morphology with fossil preservation or fossil preparation techniques or collection storage or other intended uses of the term preparations. So here's some examples of what paleo collections are putting into the term preparations. And as you can see, there's a good mixture of morphology and preparations. Probably my favorite one is one big fossil 4 centimeters there. And paleo collections are not alone in doing this. So here is a chart made by Marcus Doring showing the top 50 values in the term preparations as of October 2014. And again, you can see that there's a really good mixture of morphology and preparations. And this is still the case today. If you tried to make this same chart, you would get a very similar result. In fact, there is now over 200,000 unique values in the preparations field alone. So with the help from the Paleo Data Working Group, we've actually started to help distinguish between morphological parts and preparations. So if you visit this QR code, it takes you to a Google Sheet with this preparations field. So common paleo examples would be like 3D print, plaster cast, latex peels for those true preparations. But now that we're going through the process of separating out preparations from morphological data, paleo collections still need that solution for sharing that morphological data that researchers desperately need. So one of those solutions might be to create a new Darwin core term. So a new term, organism part, was suggested back in 2014 because again, it was recognized that the field preparations was being used for 2 distinct pieces of data. Work on this term has stalled as of 2021. However, with renewed interest from the paleo collections community, maybe we can work with the bioinformatics community to actually get this term adopted. Another potential solution may be to use a term from another standard. So Audiovisual Core recently ratified the term subject part, which is meant to capture that critical morphological data and what morphological part is being depicted in a piece of digital media. This even comes with this handy dandy controlled vocabulary to help standardize those morphological part terms, which would be super handy. However, can we borrow terms like this in order to implement them into Darwin Core? That's a good question. Or maybe there's another solution out there that we haven't even remotely thought of. So regardless of whichever solution we kind of come up with, a set of terms with definitions and guidelines on how to use those terms is critical. So on that same Google Sheet that we have for preparations, we've started a very basic notes on how we could potentially share this morphological part data. Hopefully, the paleo collections and the informatics communities can work together to kind of come up with some kind of solution to create a community-driven plan or best practices on how to record this critical morphological data that paleo collections need. We've also started creating a morphological data controlled vocabulary with definitions in use by paleo collections as a way to help standardize those values. This way researchers can really search on that one value instead of that whole suite of terms to try to find that one part they're looking for. So hopefully we can take that community-driven plan with this controlled vocabulary to really come up with the best possible solution for sharing morphological data. So to consistently and accurately share morphological data, the paleo collections and the informatics communities really need to come together to develop the best possible solution for doing this. And then once that's done, then that will increase the accessibility and discoverability of paleo collections in the biodiversity community. I would like to thank the Paleo Data Working Group for helping us to create these much needed vocabularies and brainstorming some possible solutions. I also like to thank my co-authors. There's the QR code again for that vocabulary list and our potential ways we can share this data. And thank you very much.
Thanks, Jacob. That was great. We have time for a question if anybody has one. Yeah, go for it.
So I'm very excited to see that. So thank you, Jacob. And I know the Paleo Data Working Group interested in this topic. Also, we connected at some point, and back in like I don't even remember, 17 or so. Darwin Core Hour, anybody remember Darwin Core Hour? Yes, no? Okay, so it's a thing. And one of the topics we took on was that preparations in vernacular is an overloaded term.
Yeah.
Overloaded is the fancy word, right?
Right.
So it does way too many things that make it useless.
Right.
Yeah. So Andy Bentley did a really good talk about this. So for anybody who wants an introduction to what the heck it is we're talking about, that's a really good resource. It's in GitHub and anybody can go look at it. So there's a whole, we did this sort of look inside like you did with Marcus's talk. We did, I don't remember now whether it was Tim Robertson, but what's inside that field? What does it look like? So if you guys want to see what's in there that comes from beyond paleo, but across our communities and see what a problem is in there, problemtunity. And then my question for you would be, are you considering this sort of idea of an extension to Darwin Core beyond a single term like subject part, but because preparations has got a lot of other stuff sort of tied in it? What medium did you use? Is that the medium to preserve it or the medium it was found in? And conflating those two ideas, for example.
Yeah, that's the question, and I want to bring it back to the Paleo Data Group to really kind of hammer down what do we mean by preparations.
Right. So I just want to say that I think you have the opportunity here to solve this for a much broader, or at least to open it up to a method to expand it to everybody who's trying to use that term and struggling.
Yeah.
I was just going to add an answer to Deb's question. This is part of what we are doing with the grant project in collaboration with the Paleo Data Working Group as well, is really trying to identify those spaces where we want to propose new terms or potentially extensions, or how we can support vocabularies in a way that makes them accessible, and creating this kind of shared knowledge system, also relating back to the ecosystem thing.
I'm just going to share a comment from Matt Yoder on Zoom to the room here. So Matt just says that TaxonWorks, which is a software product, can link specimens to observations, anatomy in a whole pile of powerful ways with rich semantics. So he just wants people to be aware that you can do things like draw on images to digitize specimens as ROIs, make it more compelling for the complexity of tasks outlined in this talk. And you can also integrate anatomical and ontologies by referencing, for example, OWL URIs. And you can talk to Deb here if you are interested in learning more about TaxonWorks. But Matt's comment does make me have one more question for Jacob.
Sure.
I was at the Controlled Vocabulary Symposium yesterday, and I had this question, but never kind of asked it. Okay, so say the Paleo Data Working Group comes up with a great controlled vocabulary to use for morphology or anatomy, then how do we maintain it? Like, where does that even live?
I don't know. That's a good question. And I don't know how controlled vocabularies are even implemented. So I am up to Tdwg. So there you go. Yeah. Cool.
Thanks, Jacob. Matt also shared a link to a paper in the chat related to ontologies for morphology, and if anybody wants to know what that paper was later, find me at the end of the session. Okay, up next we have Suzanne Ryder.
Hi everybody, I'm Suzanne Ryder from the Natural History Museum in London, and I'm a curator within the entomology department, looking after the Hymenoptera collection and the historic entomology collections. So I'm here to talk about a project we're doing on the Banks collection to digitize it, and we're also using the Latimer Core data standard, and I'm working with Lawrence Livermore Olga Seville and Peter Wing. And you may have been into the workshop earlier with Lawrence. So he's not here because he's moderating something else. So later, I'll try and answer some questions, but if not, go see Lawrence about the Latimer Core side. So Sir Joseph Banks is probably best remembered for being the long-standing president of the Royal Society in London, or the unofficial director of Kew Gardens, or being the pioneering naturalist on Captain James Cook's voyage on board the Endeavour to observe the transit of Venus and the search of undiscovered southern continent that we now know as Australia. Banks was a man of enormous curiosity combined with his personal wealth, intellect, powerful connections and place in society. He was able to influence and encourage and facilitate many significant pioneering projects beyond his botanical interests. Many aspects of Banks's life are well documented, but his surviving entomology collection has never actually been catalogued or even accurately listed. In 1863, the Linnaean Society in London donated the entomology and the shell collections to the British Museum of Natural History. And the entomology collection was built up through the whole of Banks's lifetime. It does include insects from the Cook voyages, but it's actually from, he collected when he was a child all the way, and gathered specimens from collaboratories around the world. So we have the collection that he collected throughout his life. So it is now housed in Darwin Centre 2 in this space with other historically significant entomology collections. So the actual number of specimens in the collection is not actually known. It's reported to be approximately 4,000 specimens, but different publications state different numbers. So we are currently undertaking a complete digitisation of the collection with the generous support of the Hayward Foundation. So the collection of insects here has historical and cultural value, but it also continues to be a relevant research tool. This is largely because Johann Fabricius, a student of Carl Linnaeus, spent a lot of time working on this collection. Fabricius arranged the collection in the order it currently sits and described many new species within it. Consequently, the collection contains many type specimens with a high taxonomic importance. So the insect collection is housed in 55 classical wooden entomological glass top drawers. The collection was rehoused after it was donated to the British Museum, hence the specimens are no longer in their original drawers. And in any conservation of historical materials, there's always an argument or a discussion about keeping everything in its original state. But after much consideration, the team decided that the long-term preservation of the collection and the specimens should be rehoused into plastizote-lined entomological drawers, replacing the current cork-lined drawers during the digitisation process. The pins really vary. Some of them are like nails and the others are so fine that they break as soon as you look at them. So even just taking them out of the cork was a consideration. So we didn't actually want to have to try and put them back into the cork. So that's really where we came from. So the current project involves taking high-resolution images of every specimen along with the associated labels. The information on the data labels is being recorded from every specimen and a QR code added. The specimens are then being transferred into the new plastizote-lined drawers with parchment sheet secured on the top of the plastizote. The layout of the new drawers mirrors exactly the position in the old drawers. So the data standard we are using to do this is the Latimer core, as it's intended to be complementary to specimen level standards such as Darwin core, providing a common way to structure and share high-level information about groups of collection objects from whole museum collections through thematic historic collections, even down to the contents of a single drawer. So here are a few slides sort of going through our decisions for what is the data standard and what is Latimer core and where it came from. It was actually produced by Tdwg as a working group. Lawrence was part of that, and Matt, who both at the museum. So they were keen that we considered this and try this for this collection because it sits very well. So this sort of shows the premise behind the Latimer core using the object group rather than the single specimen. And so this was particularly useful in the case of this important and challenging collection due to the large amount of data associated, as well as the factors such as fragility of specimens, displacement, and dissociation of information. So unlike modern day specimens, which come with data labels containing information on collecting events such as date and location and associated persons like the collector or the person that's described the specimen or identified the specimen, the specimens in Banks' collection have little or no labels attached to them. So, and this was common practice in the time where labels were seen as temporary data storage and they were disposed of when information was published. So in many cases, replacement labels were provided giving the species name or a reference to the publication. So the publication provides the species description, geographic location, often the name of the collector or where the specimen might be contained. Then later on, additional labels will be subsequently added by curators or researchers indicating type status or updated taxonomy. And at the end of the Banks collection, there's probably about 4 or 5 sort of overspill drawers where there's no data labels at all. And this material would have been examined by Fabricius and other taxonomists, but when describing new species, generally they'd only select usually 2 specimens and put them in the main series and then just leave the others in this sort of overspill. So, but it's not very helpful because we don't have that information because there are no labels. So the task of unraveling the important information about individual specimens, species groups, and specimens in the collection, including the taxonomic or type status and origin, is supported well by the use of Latimer core, as it allows a more holistic approach to collections and recording and organising broad types of data associated with it and compared to traditional standards. I mean, essentially, I think the way I see it is it's sort of a reversing of the usual flow of information. Instead of using the data from the individual specimen labels to describe the collection, we can use the information on the collection as a whole. So, and using different aspects of it, so derived from sources such as the notebooks or publications rather than the data labels, to learn about the individual specimens and the groups of specimens, such as the geographic region, taxonomic group, or who it's studied by. So, as of July 2024, 3,300 specimens have been digitised and 30 of the 55 drawers have been transferred and to ensure the conservation of the specimens, pins and labels. This has resulted in more than 5,000 high-resolution images, and the present labels have been transcribed, totaling 438 labels for approximately 1,200 specimens. So the digitization of this collection will improve its access through digital records, specimens, and draw images, and associated data that's transcribed, the labels, publications, and references, which greatly reduces the need of physical examination of these specimens. These specimens, being in the historic collection, are at limited access anyway. So, you know, it's a limited access to staff and visitors already. So, you know, it's really not accessible beyond really very specific needs, really. So this will really make it much more accessible to everybody. So, and also the digitization of the whole drawers, in addition to the specimen level images, provides another level of information. So things like the organizational system and the display of the collection. And the Latimer Core will improve the data management and sharing between data aggregators, providers and users, such as institutions, collection managers, curators, researchers, students, artists, and the general public. And when we finish this project, with the new data, we hope to produce a comprehensive catalogue of the collection utilising the taxonomic expertise of the entomologists at the Natural History Museum in London. Thank you.
We have time for a question, if anyone has one.
I have a weird question. You mentioned putting parchment over the plastozote.
Yeah.
What is this about?
Well, because it's more of an aesthetic thing, actually, because when we first did some of this with historical collections, because these things are really beautiful to look at and people do like to sort of see them as historic things. So we are using older type drawers, we're scraping those up, putting plaster in, but the white plaster looks so very white and so very bold, so we've put some parchment over the top, so it just makes it look a little bit more like a historic collection. So it is purely aesthetics.
Thanks. I think this is a really cool project, and I'm wondering in part, because I also went to Lawrence's workshop about Latimer Core earlier this morning, when you are sharing your Latimer Core data, are you doing that mostly through like the NHM London data portal or GR Cycall, or where do you picture people like being able to best access that?
The portal as our first portal, yeah, our own data portal at the museum.
Okay, thank you.
Thanks. One thing as a follow-up to the discussion about how we would maintain vocabularies. Matt Yoder shared in the chat BioPortal and the OWL protege community. And I think something that highlighted to me is where we can look outside of our immediate community for new resources as we identify these gaps and needs and how we want to expand our work. So thanks, those were great examples, Matt. We have time.
I was gonna like awkwardly talk to Holly across the room and make her say this into the microphone, but I could say it myself. I just want to point out that we do have a bunch of people on Zoom, and Lindsay Walker has been sharing a lot of resources from these talks in the Zoom. Lindsay's also been putting them in the Oxford Abstracts chat for this session. So if you go to Oxford Abstracts and search for SYM30, you'll see a bunch of links like to the spreadsheet Jacob included, that kind of thing. So FYI.
Thank you, Lindsay, as always, for being awesome at noting things. Okay, we have 2 more talks before lunch. So next up we have Talia.
All right, I guess it's afternoon, so good afternoon. I just wanted to mention, if you do want a Paleo Data Working Group Trilicorn sticker, I have a bag of them. They're precious. And we also have a fun Trilicorn stamp with a QR code that takes you to the GitHub site for the Paleo Data Working Group. So if you would like a stamp in your notebook, that'll just archive the QR code for you. It's purple ink, it's really cute. So if you would like it, come find me. Okay, so on to my talk. So I want to talk about the disconnect between local capacity and standards implementation, which is something that I have been making observations to myself about for maybe the past 10 or 12 years working on digitization projects. And I'm just going to share some of those observations with you guys today and hope that it can generate some discussion and community work on how we can bridge those gaps. Okay, so I think back in 2012, a lot of us started digitization projects in the US through the National Science Foundation ADBC project, and it was sort of like data mania, right? Like Beatlemania. Everybody's really excited to digitize, and we're doing workshops, and we're doing all this stuff. And we started generating all this data, right? I know this was my experience. And we had sort of had this mentality, like, if you digitize it, they will come, right? Like Kevin Costner in Field of Dreams, if anybody's old enough to remember this movie. My mom was really into Kevin Costner, so we watched this a lot. So I think we just thought, like, we're gonna digitize it. We had some idea of kind of what the digitization standards are. We were kind of thinking about how we were gonna share it. When we started our fossil insect TCN in 2013, I believe, iDigBio couldn't handle stratigraphic data. So, you know, it was like, how are we even going to share this data? But we're going to digitize it and people are going to use it. Like, we just had this like really positive outlook. So, you know, it's like, have specimens, we'll digitize. We have a database, like we have lots of specimens. We got students, we got equipment. We started developing protocols and workflows. Lindsay Walker, who is online, will remember she spent a couple years here in this room at this station digitizing lots of fossil insects for us. And it was a really exciting time in digitization, right? Like we were all excited to digitize and get our specimens used. But then the knowledge gaps started arising. So how do we share our data? How do we map our data to this thing called Darwin Core? What is Darwin Core? We just put our data on GBIF once and then that's good, right? Like yeah, okay. What do we do if we see errors in our data on the data portal? Like how do we fix that? Like, why is it happening? What do we do about data that don't have a place to go in our database? Like, how do we make a place to put that data? What do we do about data we can't map to Darwin Core? So Jacob's talk this morning, you know, pointed that out. What happens when we don't have IT support or changes in IT support? And I think Katie and Samantha's talk really pointed that out with the shared Symbiota resources to kind of bridge that, right? How do we keep all the software pieces updated? This is one that's been keeping Jacob and I up at night a lot right now because our university decided to stop supporting Unix servers. And I'm not, like, we're at a fairly major R1 university. So I call these problemtunities because they are problems, but they are also opportunities to work as a community to solve these challenges for the rest of our community. Okay, so the rest of this talk is just a little bit of me ranting, not even ranting, just sharing my thoughts about how we can close these knowledge gaps. So we have to start by identifying where the gaps are and then look at the opportunities for community-derived solutions. And I really strongly believe in these community-derived solutions. Katie and Samantha's talks were great examples of that. And great success stories. And I think we can use those success stories to look at how we can do this more broadly in the community. And like Katie was saying, you know, maybe it's cross-disciplinary, maybe it's regional, maybe it's whatever. But how do we do that as a community and how do we start those solutions being developed and implemented? Okay, so I kind of have 6 we'll call them buckets of gaps that I want to talk about. So how do we make modifications to our database? How do we deal with data publishing? It's very confusing. Capacity for professional development. We had a lot of folks when we started the Paleo Data Working Group that didn't know what Darwin Core was, and we had to take 10 steps back. So how do we bring everybody up? Systems administration. This is a huge problem for a lot of people, especially at university-based museums. Managing media. We got really excited about digitizing and made a lot of photos. I see Ryan back there from the CU Herbarium. I remember when you guys started doing a lot of, and it was like, oh boy, where do we put all these? How do we manage them? And then standards development versus the implementation of those standards. So it's really great what Tdwg is doing with the development of the standards, but then on the collection side, on the Spnhc side, how do we implement those, right? Okay, so just briefly, systems administration, who manages your collections databases on a system-wide level? So sometimes the basic data setup is really confusing. We just have general CU IT guy that gets, you put in a ticket and they come and do your specify thing and they don't know anything about specify and it's really confusing. And then I'm not a IT person, so I'm trying to communicate to some general CU IT person. Like I don't have the language to communicate. And then this just induces anxiety on my part every time there's a software update. Like, oh my gosh, I'm gonna have to put in a ticket and talk to some guy and then I'm gonna have to contact the software developer. Like it's anxiety inducing for me. So how do we bridge this knowledge divide between the collections staff and the folks that are needed to maintain the systems required to manage our digitized data? And I don't have answers for all of these things. I'm just posing these as questions that they are the problem-tunities, right? So hopefully we can figure out solutions together. All right, database modifications. So this came up this came up on our Cretaceous Worlds TCN. We didn't have a place to put georeference data in our specified database because it had been set up before they developed that table. So we had to go back and modify our database. So, is your database flexible enough? Can you do this? Maybe how do you modify an existing system to accommodate a new standard? Like as a collection manager, my background is trilobite systematics. I don't know how to do that. And I don't have the capacity or the time to do it. Bulk updating existing records. Is that something your CMS can do, or do you have to get an IT person to do that? So for me, the question is, how do we make databases dynamic systems that can be upgraded to change with the need of the types of data that we manage? So as those standards change and develop, how do we make it easier to implement them on the collections side? Media management is another one we're struggling with a lot, and we're talking about a lot at CU right now. So we have this big gap in how to manage associated media. A lot of us on the collection side were trained to manage physical objects, not digital objects. And I think there's a lot of opportunity to work with folks maybe in the libraries community who have already done this on our campuses or other communities, but how do we make that connection? So are there bigger community solutions for managing media? Maybe every institution doesn't need to have its own dams. Like, could we have a community dams? I don't know. Are there partners we haven't identified or partners that are under-tapped or under-resourced? All right, data publishing is another one near and dear to my heart because we had a lot of confusion around this when we started our fossil insect TCN. I didn't know how to map any of my data to Darwin Core at the beginning. It was very confusing how to take advantage of the Darwin Core extensions with the database that I was in. Do we need to have our own IPT set up? Who manages that? And then I think there's still this mentality in a lot of collections, which is I publish once and then I'm done, right? Like I did all this digitization work on this funded project and I put it on iDigBio, the end. And I don't think that that's necessarily the case. So how do we simplify this process? And again, I'm just gonna point back to Symbiota. I'm just gonna make you guys the example today. I think the two Symbiota talks were a really great example of how to simplify this process for collections. So maybe there are other solutions. I don't think that's the only solution, but maybe there are other solutions we can look at to simplify the data publishing pipeline. All right, and then back to standards development versus implementation. There's a big gap between the development and the implementation of standards used to share the biodiversity data. And I kind of talked about this before in terms of modifying your CMS and then exporting data into these new extension thingies. Like, this is not straightforward in the CMS that I'm in right now. And I was told, oh, you just have to write all this code and do all this stuff. And again, my background is trilobite systematics. So that did not work for me. And there's a lot of technical jargon that is maybe not relatable to a lot of collection managers. So how do we streamline the standards implementation and make them easier for the end users to understand? And by end users in this case, I'm kind of talking about collections community, collections folks like myself. Okay, and then lastly, I want to talk about professional development capacity, because this is something we've really been trying to kind of address through the Paleo Data Working Group, is how do we bridge that gap between what the collections staff are already doing and bring them into, like, bridge the gap between the more Spnhc things and the more Tdwg things, right? So, you know, we have these biweekly happy hours where we talk about georeferencing, we talk about standards, we talk about all these things, and it's mostly collection managers. There's a few data folks. Ben Norton, if you're online, I don't know if you're there. I don't think Ben is there, okay. There's a few more informatics-y type folks. Holly and Erica are there, and then there's like collections folks like myself. And we come together and we talk about like how we do these things. How do you implement the standards? How do you do this? How do you do that? Like, what does Darwin Core mean? We had a happy hour where we talked about that. But on a broader scale, how do we provide those accessible professional development opportunities to meet individuals where they are? And I think it's really important to meet people where they are. Not everybody is up here and going to be able to code and do this thing and, you know, just run with it. And not everybody has the time to do that either, or the resources. So how do we meet people where they are to bring people up and start just increasing everybody's knowledge base? So this is my representation of why people are important in the process. So building on Erica's talk yesterday and Holly's talk today, people are really important to this process, and people from lots of different communities. And so we need to be thinking more broadly across the Tdwg and Spnhc and the research community. They're a really big piece of this that I think often maybe gets left out, which is strange because they are the, you know, a piece of the puzzle, right? So how do we bridge all of these communities to make our data more usable and accessible? And I just want to say thank you, and let's keep the conversation going. That's all I got.
I don't know if we have time for questions, but I will read off a comment from the chat. Sorry, my screen got very dark. Alan Stenhouse poses, perhaps a set of AI-based assistants provided with your local context could help with some of these problem opportunities. Interesting thought. Oh, and Pietro says, I loved this inquisitive presentation. Embracing all those knowledge gaps is so important. Awesome. Okay, thank you, Talia. And next, for our last person before lunch, we have Gary.
Thank you to the organizers and to all of you for being here today. I'm going to talk a little bit about sort of how we mobilize data at the Yale Peabody Museum. And so this is not going to be a collections management systems talk. This is going to be more of a people, processes, and workflows-based approach to how we get people and systems to work together. And so what we're really trying to do is we've got our online portal and we've got an IPT, and we do the aggregation to sending data to IDIG Bio and Morphosource, and now this new Lux thing. So we're sending our data lots of different places, and so how do we get it there? What do data managers like myself need from collections folks to be able to make sure that those data are useful and reuseful to themselves in the future, as well as to the broader research public communities, and ensure that as we're making sure that these data are accessible to broader and more inclusive audiences, that they can be appropriately representational to the audiences that we didn't know that we had. So a lot about the little bit about the path that we take to get there. We've got a number of systems that sort of manage that whole ecosystem, where we've got archive space for managing our archival finding aids, and NetX for digital asset management, and Preservica for really helping with fixity and preservation checks and checksums on the digital objects, and making sure that those collections management's data and systems work with one another. But really the magic that makes all of that happen is a common language to sort of facilitate the transfer of bits and packets, as well as knowledge and data between each of those systems and services. And so we rely on internationally standardized vocabularies, workflows, ontologies to sort of facilitate that. And so we're going to talk a little bit about that standards-based approach, but especially how we get people to understand what each of these things mean and how to use them and implement them on the regular. So in the past, I'm new to this position, and so my predecessor, Larry Gall, has been pretty active in this community, and especially those of you that use EMU at other institutions recognize that he has a penchant for lots of photoshopped EMUs. And so when COVID pandemic had a sort of an opportunity to sit back and look at sort of some ways to fine tune and optimize performance and really get into the nitty gritty details of database optimization and performance, and really do some things with Solr indexing, Larry is way ahead of his time and really starts to put together a lot of these presentations to describe to data managers how that CMS can be optimized with the latest versions of the latest database. So there's significantly lower disk usage. The methods in which we search are optimized and improved and all that, and it uses a lot less space on the back end, and we can do some benchmarking and really start to see just how blazingly fast indexing with Solr can be. Well, that's all well and good, and especially if you've got lots of very fascinating photoshopped emus to really help tell that tale. But how does it work? Lightning Larry is a hard guy to keep up with. So what I'm trying to do is to sort of extend this continuation of emu therapy that Larry began, and to really start to put together a framework in which it's a participatory environment where people at the museum, in collections, and especially increasingly in non-collections roles, can come together and learn more about how our CMS helps facilitate access to data and what that looks like. So data could be photographs or 3D models or assets for a education brochure or a map or something about events and photographs from past events that the development office wants to use. And so we really do that in order to talk a little bit more about how tips and tricks and traps can help facilitate making sure that we are not the one person that's doing the same thing as somebody else 15 feet away or 2 floors away or a couple hundred miles away from one another, because so many of us are in exactly the same position, dealing with the same problems, with very likely the same solutions. We just don't know it. So in emu therapy, we talk a lot about insert defaults and ask lots of different people to talk about things that they have done or they have learned or picked up along the way that they feel really comfortable with, and to talk about, like, oh, this topic right here, searching after sort. You just get a nice big emu search return, you get a whole bunch of records, and just having it automatically search based on a predefined filter that you want to come back so that you can scroll through it and browse for that one particular item or object that you're looking for, really helps facilitate just the sheer number of steps, especially if you pull up a couple thousand object records at one time. We also have built some tools and applications to facilitate large asset uploads for like CT scanning, et cetera. So how do you use the ingester web application? How do you use, what is this IIIF thing? Why does it matter that I have to have a format that is going to be acceptable and work well with the way in which we've implemented IIIF to make sure that all of these images can show up in a nice, handy browser plugin that shows up on the web? And then how do we make sure that that shows up in such a way that the asset's going to be there, people can see it, see what the metadata are that go along with that asset, and then all of the other views of that specimen or all of the other objects in that accession lot and do that so that way that those images are related with one another, foundable in the same spot, and then also preserved for perpetuity in our digital preservation system. Some of the other things that we're really starting to cover are willing to engage our artificial intelligence powered workflow. So if we're leveraging some of the latest and greatest that comes from our dams, searching by color is a new thing where you can just put in a hexadecimal code, and all of a sudden, if you've got a graphic designer that's looking for a graphic that just really matches her color palette, you can do that and find every specimen in your collection that now matches that hexadecimal code for that particular palette. Searching for objects contained with images, even without metadata to describe all of the objects or the multiple specimens in a particular photo. These types of possibilities and more are now being facilitated by artificial intelligence powered pipelines. Kind of just speaking to the comment that Holly read aloud, or Erica read aloud in the last talk, AI is really helping to move some of these things along. And in particular, we're now starting to look a lot more at time-based media. As we're digitizing film and other VHS, audio cassette, other kinds of formats for people doing a drive-by description of outcrop along a highway. These kinds of formats are things that we want to preserve in digital formats for years to come. And Aviary is a new platform that we're starting to look at because it's a free and open source platform that uses AI to automatically generate subtitles and text from the image that you can then push alongside that object as a text file. So you've now got a text-based transcript, embedded subtitles in the video itself, and then that becomes a search index for finding videos about the subject that you're looking for, so those pop up in your search results as well. Some of the other things that we've been trying to do and working with interns and students at the Peabody Museum is trying to explore new ways in which artificial intelligence can sort of help make a collections manager's job easier. So using optical character recognition and handwritten text recognition for extracting information off of labels. Handwritten text recognition has come leaps and bounds in the past 6 months alone, much less in the past 8 years since I've started working on it. And so when you start to couple that with named entity recognition, you can start to say even without structured data sets, individual boxes and coordinate points on a label, where things go because they match the broader definition and dictionary of terms that you have in your collections management system that you can start to sort of use as that training data set to say, oh, this term looks a lot like all of these other terms. I think it needs to go here, even though you don't really know what that concept is as a machine without a brain. And then multimodal and generative AI contributions can really start to help with label transcription, validation, and speeding up those labor-intensive processes. And then really starting to do image classification to add contextual metadata for legacy data. So we're really starting to look at, for those users and those consumers of our data on our web portals that don't have access to EMU or don't know to come through our collections management system, what is that object? How did it get into the collection? What is the provenance of that particular digital object? So we're starting to look at ways in which we can add information and go through a couple hundred years backlog of information that has accumulated by adding more and more contextual metadata to those objects to make them more readily discoverable. Because when we have feedback mechanisms in place to allow for the public and research communities and others that are using these objects and reusing them, they can tell us more about, oh, I learned this thing, or that's not exactly right. We can begin to take that feedback and make some improvements to the quality of our own data as well. We're starting to use a lot of this, especially in conjunction with the new Lux data aggregation portal at Yale with the art museums and the galleries and the libraries all together. And so we're starting to use automated data quality pipelines that are looking at Wikidata as a reconciliation service using tools like OpenRefine and Python to really start to say, there's lots of other contextual information out there. How can we use those services as ways to improve the collective understanding of what's out in collections across the world to improve what might be a typo or a name that was lost to the sands of time within our own collections databases. And then especially we can find these things where we get little bizarre hallucinations that start to occur, even though these, because when you have a documentary that's archived in the libraries about Cuba, but it was produced in Florida, and then the library puts subject heading tags on that particular work saying that it was produced in Florida, produced in Cuba, and that Florida and Cuba are now conflated to be the same thing, and says, oh, well, this now specimen is located in Cuba, which is part of Florida, which is part of Cuba, which is part of Florida. Like, it completely blows up and loses track of its mind. And so we need to start to put in a little more understanding about how each of those entities can be resolved with additional context added to it. And so, especially by reconciliation with Wikidata and a lot of information that we don't already have in that central authority, our collections management system, Wikidata can tell us, oh, that collector that we have, yep, that's the same one that we've got in our database. Yep, oh, wait, shoot, that person was born 30 years after that specimen was collected and was attributed to them. There's a problem there. And so it's really helping us to clean up spurious attribution in our records, especially when we find that there are 3 George Coopers. Is this George Cooper Jr., or Mrs. George Cooper? Is this another George Cooper that is not the same George Cooper we were looking at before? And what happens when provenance information can help us to differentiate that, because the collection's agent information wasn't necessarily enough to differentiate between each of those 3 George Coopers. And then we're really starting to lean into standards documentation and making sure that the standards module in EMU allows for us to make sure that we're on the same page with other institutions that are also implementing Darwin Core and Audiovisual Core and Latimer Core and all of these other standards and frameworks in our collections management system, so that we can stay abreast of how everyone else is doing things in the same way, and that we can continue to formulate this community of practice that allows for us to understand these standards, to implement them similarly, so that way we can all have achieve collective benefit from implementing them all together. And then finally, we're also going to start to build a lot of our documentation to sort of extend the workflow that we have and sort of model that after the work that's been done at the Field Museum and others. And just want to also mention that a lot of this work is going to be featured further in the digitization coordination session tomorrow morning. So a lot more information about how to sort of tie up all of this together. So with that, I'll end there. Thank you very much.
We definitely have time for questions. While you think about it, I'm going to read this to see if I need to. Is this a question to read? Okay. We have one question from the chat from Pietro. Question related to machine learning models for high throughput image classification that add contextual metadata. Have you investigated this with morphology in 3D models? E.g., could we search for specific bone sutures intersections in a set of 3D models?
We have not gotten to that point just yet, but I'm sure that those capabilities are not too far away. I know of a couple of colleagues that are starting to explore those things, but I do not have experience with them just yet.
Thank you. I will take this moment to say thanks to all of our speakers. I think this was great. It was really interesting to hear your contributions, and a reminder to everyone to please join us again tomorrow, same time, same place, for the second half of this symposium.